In a world on North Carolina State's campus, there were 4 NC State students, all in the same E101 section, put together in order to complete a task, and that task is to build a fountain that trumps all fountains. Unfortunately, we got 10th, but that's not the point. Here is our presentation.
When coming up with the ideas for the fountain that we planned to build, we followed the different elements of the engineering design cycle. We first looked at the different requirements for our fountain and whether we wanted to use a pump or not. Each option had its own additional requirements, but we decided not to use a pump in our final design. We looked at different examples of fountains throughout history and past projects while trying to figure out how to make our fountain work. One of the first ideas we had was to use a simple system that used only water pressure to move the water against gravity. But when we realized that would require more water and space than we had available, we went with Heron's fountain. This system used a combination of air and water pressure through many chambers to move the water against gravity and out of the top. Our initial prototype was a smaller scale version of Heron's fountain that used plastic tubing, water bottles, and superglue. We used this to test how long the fountain could run, the length and strength of the tubing needed, and where there could be problems with the seals being airtight. After we tested the prototype, we learned that the initial design would work and could run for several minutes, but that we would need to find better sealants to use around the bottles and tubes.
By looking at our prototype, we decided that 5-gallon buckets would be the best option to make sure the fountain could both be easily transported and filled while also running for as long as possible. The same type of tubes could be used in our final design because they were able to keep the water flowing for a long time. We used caulk to seal between both the tubes and buckets to make sure that everything was airtight, and we added easier options to drain and refill the buckets between cycles.
One of the design challenges that we came up with while building the fountain was related to how we were going to seal the buckets and any small air leaks around the tubes. One of our first tests showed that we had problems with water leaking out of the area between the buckets, so we had to go back and re-caulk that area. The second test showed that when we resealed the area between the buckets, the seals between the two tubes right in between the lids came undone, so we had to reseal those areas as well. In addition to the challenges with the caulk, the main challenge that resulted in our fountain not performing as well was having everything sealed airtight. In our design, we had a hole in the top of the bucket to refill it. It was difficult to seal the hole and still be able to remove the seal to refill the bucket. We ended up using a type of putty that stuck to the bucket and was easy to remove, but in the end, that was our flaw to the design. Another challenge we came across was how we should design the outside of the buckets to make the fountain more aesthetically pleasing. We went through many options that included painting the outside and using food coloring in the water, but we settled on our final design being based on a well.
While we did not perform as well as we would have liked, we still had a great time at FEDD. We were the only fountain team to not use some form of electric pump, which was very cool to see. However, with that uniqueness came the added risk that our design would not perform for the judges, which is exactly what happened. While our fountain did work before and after the judges left, it did not work while they were watching. Because of this, we were deducted points and finished 10th out of 18 teams.
We have several main things that we would change if we were able to do this project again. First, we would develop better ways to seal our design to hold both water and air. Because our design doesn't have a pump, it's entirely dependent on both water and air pressure in order to succeed, in order to move water upwards. And so these pressures place a great deal of stress on every junction of the design. And so if we were able to redo this project, we would definitely experiment with different methods in order to seal those gaps better. And this better sealing would have solved the problems that we had on the day of FEDD where our sealing failed. The second thing we would change is building a mid-sized prototype. So in our design cycle, we ended up jumping straight from a small-scale prototype made out of only water bottles to a full-size model made out of 5-gallon buckets. And this large scale-up caused several design challenges that we weren't anticipating ahead of time. So if we had made a mid-sized prototype, that would have prevented those scale-up problems and made building the final model much easier. And just like we have advice for ourselves about what we would do if we were able to do this project again, we definitely have advice for what we would tell next year's freshmen. Just like we know what we would tell ourselves if we were to do this project again, we definitely know what we would tell next year's freshmen as they approach this problem for the first time. And that is that something that you don't realize when you first begin is how difficult scheduling will be. When you have 4 people with 4 different schedules, Finding times when all of you can meet will be tricky. And for this reason, the number one piece of advice that we would give to next year's freshmen is to get started on the work early. This gives you more time to work through scheduling issues, to tackle any design challenges that come up, and to test your final design enough to work out the kinks. Overall, the earlier you begin working, the easier your project will be.